Welcome back to section 9.3. We're going to move on to the critical value method. Because we're dealing with t-scores here, we're going to continue to use the TI-84, and because in matched pairs our n's are the same, the degrees of freedom will just be n minus 1. And just a reminder on how to find the critical value t after we get our test score. So in example 3, we're doing the heights of mothers and daughters. And what this one is saying is use a 0.05 significance level to test the claim that there is no difference in heights between mothers and daughters. No difference. So the claim here is no difference between them. So essentially saying that the difference is 0. So the difference here would be if we were to take the mothers, we'll make that 1 and 2, the mothers and subtract the daughters. If there's no difference, it equals 0. So the difference is equal to 0. So our null is our claim that the difference is equal to 0. And our alternative would be not equal to 0. So let's go ahead and type our data in. So I'm going to edit the data here, and I encourage you to enter it as well. Maybe press pause here and come back when your data has been entered. So I've got all my data in here, and I'm going to store my L1 minus L2 into L3. And then I'm going to run the stats t-test. And I've got the data here, and then let's just go over and see our alternative is not equal to. So we get our test statistic here of negative 1.379. Negative 1.379. So now we're going to use the critical value method. So we actually have a two-tailed test here because our alternative is not equal to. And what that means is our alpha, our significance level, gets divided by 2. So this is 0.05 divided by 2, and this is 0.05 divided by 2. Now, if we want to get this t-score and this t-score to compare it with our test t, our critical value, we're going to go into the calculator, and they are symmetrical. So if we get one, we can get the other. So we're going to go into second VARS, INVT. Now the area to the left is going to be 0.05 divided by 2. And let's see, how many degrees of freedom here? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our degrees of freedom will be 9. And we'll paste this. And we get that negative t is negative 2.262. Negative 2.262. That means this one would be 2.262. And now our test value is, so this is 0. So think of another number line. Our test value is going to be somewhere right here. So this is in the fail to reject region. Fail to reject the null. So we are failing to reject the null hypothesis. So there is not sufficient evidence. So fail to reject is almost like accept. So there's not sufficient evidence to warrant rejection of the claim. So it's probably true. So fail to reject, and here we go. I'll just show you the sentence here. There is not sufficient evidence to warrant rejection of the claim that there is no difference in the heights between mothers and their first daughters. So go ahead and give this one a try and press play when you're ready to see the solution. You can use the critical value method here. If you're really stuck on the p-value, go for it. It's good to try it. And there's the solution. Now, confidence intervals here, we're still going to use the calculator. We're still going to enter the data, and we're going to use the t-interval instead of the t-test. But the way we're going to get the confidence interval will be through that, and we can find the margin of error by taking the upper value that we get and subtracting the mean value of the differences. Now we can actually find the mean value of the differences. Remember, the differences are going into L3 by running one variable stats on L3, and that would give us the mean of the differences. So here we've done this data before, which is why I'm like, oh man, I wish I would have kept it in L1 and L2. And we're going to use the same sample data. We're going to construct a confidence interval estimate, which is the mean of the ages, and then find the margin of error. So for this example here, Our null hypothesis, if we go back, is setting it equal to 0, and our alternative was that it was less than 0, and then this one was our claim. And to determine our confidence level, which we need, we have to say, okay, is it a one-tailed or a two-tailed test? So this is a left-tailed, so it's one-tailed. And our significance level is 0.05. So because it's one-tailed, we'll double it, and we'll do a 90%. Double that 0.05 to 0.10, and that means it's a 90% confidence level. So let's go in, and I have to re-enter all this data back into my L1 and L2 and clear these out. So press play when you have L1 and L2 in. So now I could just enter the differences, but usually we don't get them, so I'm just going to practice that. So that would be L1 minus L2 I'm storing into L3. Now I'm going to go into stats, test, and I'm going to do T interval. Oops, stats, test, T interval. And the data is in L3, and the confidence level is actually 0.90. So I'm going to calculate this here, and I get negative 24.17, so the confidence interval, negative 24.17, these are years, the difference, and on the other end we got 3.77 years. So when we look at confidence intervals, we're basically saying, does it include 0 or not include 0? And it does include 0 because we go from negative to positive. So it does include 0, which means that the differences could be 0. So it does not support the claim. The claim says that it's less than 0, and it includes 0, so there is no significant difference in ages. And now if we want to find the margin of error, we can take our upper claim and subtract the mean of the differences. So our upper is 3.77, and now to get the D bar, it gives it to us right there. That X bar is the differences, and that's negative 10.2. So we're going to subtract negative 10.2. And so we can see that the margin of error here is 13.97. So we have a 95% confidence that the limits of negative 24.2 years and 3.8 years contains the true value of the mean of the age differences. And in the long run, 90% of such samples will lead to confidence intervals that actually do contain the true population mean. And because the confidence interval includes the value of 0 a year, it is possible that the mean of the difference is equal to 0, indicating that there is no significant difference. So now before you did two problems, you're going to do the confidence intervals, and I did give you the confidence levels, but I would encourage you to make sense of why those are the confidence levels, and then press play when you're ready to see the solution. And that concludes section 9.3.